So y'all can see my screen. Anyone can see my screen?
Yes.
Okay. So we start.
Yes, sir. Yes, sir.
Yes, everything can hear my voice clearly, Okay. So this is 6516. This one is without BT but I use the picture. Now today our demonstration is on the BT type Bluetooth type. Okay. This 6516, they have a few. You see my cursor here? You see my cursor? Okay. There's a continuity test, insulation test, loop test, RCD test, voltage, phase rotation, and earth test. Okay. I will explain to you why we need this function and explain to you the application of this function before we. I think the application is important. We know the application. Then after that we use it. We try. After that we go and understand how to use this. I think it is better, right? So first of all, some of you may not know what is earth wire, what is live, what is neutral. Okay, never mind. I start from basic. Okay. So previously the old wire is this color code. Green is earth, red, then red is live, black is neutral. Now the standard change to a new wire color code. Okay, brown is live, blue is neutral, earth is green, yellow. Okay, so y'all must know if y'all want to touch electricity, y'all must know these three wire. It's very important. Okay, so live. What is the use of the live? And actually, we only need to use these two wire, live and neutral. Okay, live when the current pass through the live, then it will return back from the neutral. Okay, it's a loop. Okay, it will power on your appliance using these two live and neutral wire. Okay, but sometimes there is a leakage current. So this leakage currents may go through the earth. So we need the earth wire. So this is why we need these three wire. So the earth here, okay, the earth here, some people they know it as ground. It's also as ground. It's the ground that we step on it. Okay, this wire will connect to the ground. We step on the. Now we are step on the ground. Okay, this is ground, earth. Life is also called phase. Okay, understand? I hope you understand these three. So we proceed further. Okay. So one of the function of our instruments is to test the continuity test. Okay. This diagram shows equal potential bonding. You can see my cursor here. Equal potential bonding means equal voltage bonding. Okay, so meaning to say this earth, all of this earth, all of this wire, this wire is connect to the earth. Okay, connect to the earth electrode. This is called electrode. So the earth normally is 0 volt. So meaning to say this all wire is 0 volt. Okay. The continuity test is normally they go and test the earth. Okay, the earth. Okay, the continuity test that is actually is not relevant to this equal potential bonding. Okay, what actually is continuity? Continuity is, for example, you see these instruments connect both ends here. Okay, this circuit is continuous. Okay, continuous. So this continuity test is to test to make sure this circuit is continuous without breaking. Okay, understand? So if continuous, here the resistance value will show below 2 ohms. Normally it's below 2 ohms. Okay, resistance value will show below 2 ohms. Okay, if over than 2 ohms, like 2000 something ohms, there is something happen to your wire already. This cable may break. Okay, understand? So this is called continuity test. Okay. Now we move to other function. Okay. So what is insulation? Y'all can follow me, right? Hello? Hello?
Yes.
Anyone?
Yes, sir.
Yes, sir.
Okay, can. So I proceed. If y'all can hear, y'all can't hear my voice, y'all let me know. Then I just present. I just proceed. Okay. So what is insulation test? Okay. Your cable, these three cable. Okay, this is copper. Okay, you see the end here. This is copper. Copper is a good conductor. Okay. This one, this is called rubber. Okay. Okay, normally the copper is protect the cable. There is a rubber to protect you from electric shock. Okay, when you go and touch brown wire, you touch copper, you will get electric shock. Okay, you touch this isolator, touch this insulation, you will not get electric shock. So this is why we need the insulation test to test whether this three wire is this the isolator here. Okay, this green color rubber, this chocolate color, brown color, blue color. This color is a rubber. Okay, this rubber is a isolator. It's all isolator or okay, sorry, it's insulator. Sorry, insulator. So means it protect you from electric shock. So insulator, I think something is in. Someone is in. Wait, Hello. Yeah. So I continue. You can see my screen. Okay. So I continue. So this is called insulation test to test whether this rubber still working in proper condition, do not deteriorate or anything. Okay, so this is called insulation test. And then you got notice of this circuit. Okay, insulation test, we no need power supply. Okay, please cut off your power supply. Then another one is, you see here is your appliance or your equipment. Okay, insulation test, we need a 500 volt DC or 1000 volt DC, okay, to test the insulator. Okay, so this 500 volt and 1000 volt DC go out from the instrument to test the electric circuit under test. It may spoil your appliance, may spoil your equipment. So please cut off this equipment, okay, before you run the test. Okay, understand? So another thing is, okay, insulator is not a good conductor. Normally, the resistance is very high. Okay, the resistance is in mega ohm. So later you will see the test result is all in mega ohm. Okay, understand? So I move to other function. Okay, inside the insulation test, there is another function called SPD. SPD is a surge protecting device. What is this surge protecting device for? Okay, you see the right hand side corner here. This is a surge protecting device. Normally, this usually used in Europe, more in Europe. So this surge protecting device is to protect the lightning. Lightning, there is 3,000 over million voltage come in. Then this is your sine wave. Okay, voltage there is a sine wave. AC voltage there is a sine wave. Okay, when there is a high surge voltage, there is a lightning, then your voltage will be have a transient spike, transient or spike. Okay, this transient voltage may spoil your equipment. Okay, so this protective device is to cut off your circuit to protect your device from harm. Okay, understand? But inside this demonstration, I won't show you this as SPD test because I don't have this thing. Okay, so I show you here. Okay, here is a press to start button. Okay, later I explain to you. This one you just connect to both ends, then you start the test. You change to SPD function, then you start the test, connect like this. Then it will start from 0. It will count start from 0 volt until, for example, here you see the right hand corner here. You can see my cursor here. 0 volt up to 700 volt, it cut off. So meaning to say this breakdown voltage, this SPD, the breakdown voltage is DC 700 volt. So this SPD function is to test this breakdown voltage of this SPD. Okay, understand? So this you test it, it'll show you AC. AC is a conversion of the DC voltage. Is a formula, I think. There's a formula to convert DC to AC. So it's a calculation only. So the breakdown voltage for this SPD is 700 volt. Okay, so to test this function is to test this breakdown voltage. Okay, understand? All understand? Okay, I move to other function. Okay, now we talking about RCD. Okay, do you know what is RCD test? Okay. Okay, RCD, what's the function of RCD? This one I explain to you now. Okay, you see, the right hand corner here, there is a, sorry, here is the diagram, okay. Okay, here is a live wire. You see, L1, here is a live wire. Go to the load, then come back to neutral. I explained to you just now, the current pass through to the live and then go to the load, then come back from the load to the neutral. Okay. In the normal conditions, the current pass through the live wire, and then go to the load, come back from the load to the neutral wire. The current is the same. Okay, the current is the same in the normal condition. Okay, I'm talking about normal condition. If there is leakage current in your load, okay, there is leakage current in your load. So the current come back from the neutral may not the same. Okay, may not the same. So this difference of currents if higher than your RCD tripping currents, so your RCD may trip. Okay, the RCD is to test the imbalance of the current from live to neutral. Understand? Okay. Then the tripping currents, the tripping times, if follow the IEC standard, there is standard to follow. For example, for final circuit up to 36 amp for socket outlet or up to 32 amp for fixed connected load. In the TT system and TN system, the requirements is different. Must be lower than 200 millisecond or 400 millisecond for TN system. It's very fast. If your RCD trip in 1 second or 2 seconds, what will happen? People go and touch this one. People touch the unsafety equipment. People will get burned. Okay, so it is important for RCD to trip when to prevent people from to prevent the human from electric shock. Okay, understand? And in our instruments, we test the tripping time. Okay, how many seconds? Okay, and tripping current. Whether this tripping current is still under the safety value, safety range. So this is two of the tests why we use our instrument to test. Okay, understand? Okay, we go to this UC voltage. UC voltage. Okay, this is a TT system. Okay, TT system normally there is a local earth here. There's a local earth here. Okay, better explain to you what is TT system and TN system. Okay, now principle of the UC measurement ground being imperfect. Okay, for example, this ground is imperfect. There is a fault current flow to this R. Okay, for example, okay, to let you know before I explain more, UC voltage there is a function under RCD test. Okay, under RCD test. Later I will show you the test. Okay, then I proceed. Then if there is a fault current happen in this local earth, so the electric potential may occur. There is a voltage. So got voltage, there is a current flow. Okay. There is a possibility a person go and contact this imperfect ground. It's called a voltage. Okay. So this voltage called VC, called touch voltage. Understand? So how to calculate this? How to calculate this UC voltage is using the rated resident current. Means your RCD rated current times the impedance measure. So normally we get the result is lower than 50. Lower than 50. Later I'll explain to you why it's lower than 50 or yeah, it normally is lower than 50. If higher than 50, your instrument will show something here. Okay, so you'll just noted on this, UC voltage. Later I will go and run the test. Okay. Okay, now we go to another function called loop impedance. Loop impedance, okay, if an electrical installation is protected by an overcurrent protective device, this overcurrent protective device means MCB or fuse. Okay, the up loop impedance should be measured. Okay, this is the condition you must meet. If an electrical installation is protected by a protective device, MCB or fuse, the up loop impedance should be measured. This is the condition. If your circuit have breaker, you need to test the impedance, whether the impedance is in safety for this circuit design or not. Okay. In the event of fault, okay, in the event of fault happen, okay, the earth fault loop impedance, so the impedance that we measured must be low enough, and the prospective fault currents must be high enough to allow the automatic disconnection of the electrical supply by the circuit protection device within a prescribed time interval. Understand? So I can explain this to you with this formula. Okay, you all know what is voltage, what is current, what is resistance. Voltage, current, resistance, there is a pyramid formula. If we want to measure voltage, I times R. Okay, I show you here. Okay, this one later I touch. So this formula I explain to you what is this pyramid. If you want to measure voltage, current times R. Okay, if you want to measure the current, voltage over R. Okay, if you want to measure resistance or impedance, voltage over I. Okay, understand? Okay, so in the second here, we mentioned if a fault if a fault happen, a fault loop impedance should be low enough. Means this resistance must be low enough. Okay, this formula show what? R is inversely proportional to I. Okay, meaning to say when resistance is low, resistance or impedance is low, the current is high. Okay, understand? You all know the mathematics. Okay. In the event of fault up loop impedance, should be low enough. So meaning to say this impedance should be low enough, and the prospective fault current, the current is high enough to allow the automatic connection of the electric supply by the circuit protection device with a prescribed time interval. So in this condition, this impedance is related to the protection device. So this condition must meet. If you have a protective device in your circuit, the impedance must be low enough. Okay, understand? So the impedance must be low enough and follow the safety standard. There's a standard to follow. Later I will show you. Okay, understand?